we should be able to graph a transformed parent function and quadratic parent function by using our transformations. And sometimes it will look in the form of y is equal to, or f of x is equal to, a parentheses x minus h squared plus k. We refer to this form as the graphing form or as the vertex form. The reason why it's a vertex form because the value of h comma k will be our vertex of our equation. The other thing we need to notice is that sometimes we're given our quadratic equation in standard form, where it looks like f of x or y is equal to ax squared plus bx plus c. Both of these are quadratic in nature, and both of them can graph the exact same parabola. It just depends on the values of a, b, and c, as well as hk. I will note this though, that the a that we see in the standard form is the exact same a that we see in the vertex form, so that doesn't change. However, we're going to notice that it's very difficult for us to graph something that is in standard form. So we would want to be able to change our standard form into our vertex form so that we can graph. We do this by completing the square, and that's what we're going to talk about today. The steps for completing the square are listed here. There's 4 steps. We're going to do an example at the same time so that you can see what we're talking about. The very first thing we want to do is to get 1x squared, which means if you have a number in front, which we do, that's this 2 that we have, we're going to have to factor it out of the x squared and the x. So let me show you what we're going to do. Because we have this 2, we're going to do a GCF of 2 from both the x squared term and the x term. Notice we're not going to do it for the 16. The 16 we leave it on the outside of our parentheses. And we can see here that 2 times x squared will give me my 2x squared, and 2 times 2 will give me my 4x, and I need it to be positive. Alright, so that's step 1. We are able to get a on the outside, and we GCF out or factored it out of the x squared and the x term. The next thing we need to do is go find h and h squared. So in order to do that, notice it tells us if you want to find h and h squared, I can tell you h is 1/2 the coefficient of x. So let's come over here and do it for our problem. So we know that h is equal to 1/2 the number in front of the x. Well, the number in front of the x is 2. In fact, it's a positive 2. So we find that h is equal to a positive 1. And h squared is equal to 1 because 1 times 1 is 1. So we have been able to find h as well as h squared. Step 3 says add h squared in the parentheses and subtract a times h squared out of the parentheses. So let me show you that. That's probably the hardest step that we're going to find. So what we're going to do is we're going to get our f of x. We had it in the form of 2 parentheses x squared plus 2x. Notice I'm going to leave some space, minus 16. And in step 3, our job is to add h squared. Well, h squared was 1, so I'm going to do add 1 on the inside. And I need to subtract a times h squared. Well, check this out. A times, here's a, times h squared. So I'm going to multiply that. And on the outside, I am going to subtract that. So in other words, 2 times 1 is 2, and I'm going to subtract the 2. So we can see where the 2 came from. That's 2 times that 1. It's minus because it said we needed to subtract that value. So now that we've done that, let's simplify what we have. So we did that on step 3. Step 4 says what you want to do for your f of x is to factor the parentheses. So I'm going to keep this 2, and I'm going to factor this parentheses as something squared. And it kind of tells me right here, it's going to have an x plus or minus some number. In our case, it's going to be x plus 1. Why 1? Because h is equal to 1. More importantly, remember this is a perfect square trinomial. This part right here is a perfect square trinomial that we've created by completing the perfect square trinomial by adding that 1. And on the outside, we're going to add these numbers so that we get minus 18. And we're done. We have converted our general or standard quadratic equation into a vertex form or graphing form. Since it's called the vertex and graphing form, let's go find that information. What we notice is that the vertex is going to be located at -1, -18. Remind yourself that when we're looking at the transformation horizontally, we let this parentheses x plus 1 equal to 0 and we solve it. X is equal to -1. That's our value that we found right here for our x value. The y value is going to be whether we moved it up or down. In this case, we moved it down 18 units, so our vertex will be located at -1, -18. The other thing we need to notice is that we can find the axis of symmetry is always going to be x is equal to the value you found when you're looking for your horizontal translation. So it's going to be x is equal to -1. I'll give you another hint. It's always the same x value that you found for your vertex. Lastly, we can go find other items. So for example, we can find the value of f of 0 of our function. And then for this one, I'm going to use the one we were given, which said if you're going to plug in 0, you're going to do 2 zeros squared plus 4 times 0 minus 16. And we can quickly see that f of 0 is equal to -16. This is the point 0, -16, which is our y-intercept of our graph. So we were able to do that. And the next step would be to go find our x-intercepts. And I'm just going to leave you with the hint on that one. To find the x-intercepts, we would set this function equal to 0 and solve for x. And we can do that for either the graphing form or we can do it for the standard form. Either way, we're going to talk about that next on how to solve quadratic equations